Our next presentation comes from, and our final presentation for today comes from Jason Driver of Michigan DOT. Jason will be discussing some of the Michigan DOT's research, his presentation on investigation of bonded overlay adhesion as it pertains to concrete age and pre-application of silane sealers.
All right, thanks, Bill. So I'm going to be talking about some of the Michigan DOT best practices for thin epoxy overlays, as well as, like you said, Bill said, some exciting new research that we've done. Our thin epoxy overlays have become just another tool in our toolbox in Michigan. We've been applying them since the mid-1990s. We've had a very great success with them. Since 2006, our state forces have applied roughly 2 million square feet of thin epoxy overlay, and our Michigan bridge contractors have placed roughly 9 million square feet of thin epoxy overlay on our bridge decks. We've had several innovations over the years, and we've really got a really good tight spec scoping process that we use. And for scoping thin epoxy overlays in Michigan, we pretty much look at any deck that's bridge deck that's 1 year or older. We like to see our new bridge decks go through at least one season, one cycle of weather to see how they're holding up before we cover up the surface. For our older decks, we look at any deck with a deck bottom rating of fair or better. If your deck bottom is already bad, why bother? We also look at a deck surface with a condition that doesn't have more deck patching necessary than would require a rigid overlay. And also, some of our older decks, the tining is worn off or never had tining to begin with. We're just looking for a general increase in our skid number. Typical skid number on tined Michigan bridge deck is only 40. Typical skid number on Michigan bridge deck with our thin overlay system is 65. This is not, we don't use a calcined bauxite on all of our thin polymer overlays. So this is just with our standard aggregate that we use. The life expectancy of thin epoxy overlays with proper surface preparation, because surface preparation is everything. Thin epoxy overlay treatments will last 15 to 20 years in Michigan. Some of our older thin epoxy overlays may have some cracks in them. You can repair those, chasing them with a healer sealer epoxy. You can repair delaminations. And then at the end of life, we're having a lot of success with fully polished, or the snowplows have removed enough of them, with milling off the old thin epoxy overlay and replacing another one. We really like our specification in Michigan. It pretty much guarantees that we're going to get 15 to 20 years life. The first thing, and not listed on here, I want to mention, is that we require a 5-year warranty from our contractors on our thin epoxy overlays. So that really incentivizes the contractors to do it right and not cut any corners. Because in our experience, if there aren't any corners that are cut, the thin epoxy overlay will fail within the first 2 to 3 years. So that 5-year warranty, if it makes it 5 years without any problem, we know that it was put on correctly, and we're pretty much guaranteed that it's going to last 20 years. Our specification follows closely the ACI 5033 specification for producing skid-resistant surfaces on concrete. The next couple of slides, though, will show you how we have tweaked that specification a little bit to fit Michigan's needs and guarantee the 20-year life. Our first deviation is most people and most specifications call for a Mohs hardness of the aggregate of 6. Our Michigan plow blades have equivalent Mohs hardness of 7. We call for a 7 minimum Mohs hardness on our aggregate and our specification to slow down the polishing of our aggregates. Another deviation, the ACI spec only indicates that the surface to receive epoxies are to be free of loose and unsound materials and contamination that will affect the cure or adhesion. We kind of look towards ICRI. The ICRI states the CSP of 5 or greater for thin overlays. So in Michigan's experience, to get the 20 years and guarantee that we're getting adhesion, our spec calls for a CSP of 7 or greater. And really that's kind of to help out our inspectors. If the contractor is only shooting for a CSP of 5, there could be areas less than a 5. But if they're shooting for a CSP of 7, you're almost guaranteed to not have any areas on the deck less than that CSP of 5. Here you can see this is just the ICRI table that talks about where you should be at for different surface profiles. Moisture tests in the ACI spec says evaluate moisture content for concrete by determining if moisture will collect at bond lines between concrete and epoxy coating before epoxy is cured. That doesn't specify moisture content percentage. Some people try and use a moisture meter, make it an exact science. In Michigan, we just don't use that and we don't allow it. We go with the ASTM-D 4263 moisture test, which requires the 4-foot by 4-foot polyethylene sheet taped to the deck. And we evaluate for the condensation. Our test time and our specification is based on the selected product that the contractor is using and the manufacturer's expected cure time given atmospheric conditions at the time of installation. So it can vary, but it is what we expect to get that excellent cure time. And another thing is to make sure that the contractor doesn't just dump a bunch of epoxy into a 5-gallon bucket and see how long it takes to set. Epoxy is a very exothermic reaction. That set time won't match the set time that is going to be on your deck. The contractors have to follow the manufacturer's guidelines for set time and temperature. Thin overlay surface prep. Surface preparation is everything for the long-term performance of an epoxy overlay. All soft, weak surface mortar latenance carbonation must be removed to allow the epoxy to bond to the aggregate within the concrete matrix. We pulled this out of a couple of sources, and you'll notice that it doesn't say allow the epoxy compound to bond to the cement paste or anything else. It says bond to the aggregate within the concrete matrix. And it's for that reason that in Michigan, we require our deck tining to be removed. All of our deck tining is installed wet, and it is our belief that the wet installation of the tining will push the aggregate down. So if you're not removing your tining and you're installing your tining wet when you're pouring your deck, then you're not getting as much aggregate exposed and you're not getting as much aggregate to adhere to. Like Greg said, paint striping is a bond breaker. Paint striping has to be removed. And if any unsound areas are discovered, you have to delay the application. Most manufacturers will not recommend their product be placed over concrete less than 28 days old. And lastly, once the surface is prepared and ready for the overlay, vehicles are no longer allowed on the prepared surface, except for the one vehicle that is distributing the epoxy and the aggregate. You see here in the thin overlay surface prep that that there is plenty of aggregate exposed, the paint striping has been removed, as well as the deck tining. Greg kind of covered this already. This is just ICRI surface prep chip. So it's a helpful tool to make sure that all your inspectors, if they're going to be on a thin overlay job, they've got these on hand. I pass them out to Michigan DOT's inspectors like Halloween candy. Here's where we kind of transition the presentation. So Michigan has been applying these thin overlays since the mid-1990s. And like I said, most manufacturers will not recommend their product be placed over concrete less than 28 days old. And that ends up being somewhat of a problem in construction. We're always getting the question, well, can we install it earlier? So the rest of my presentation will focus on how Michigan has investigated ways to shorten this time. One of the first ways, the easiest ways to sharpen your tools is to attend these AASHTO TSP2 Bridge Preservation Partnership meetings. It's where I got the access to vendors for innovative materials, and that's where I started testing non-cementitious patching materials. This led to MDOT developing the special provision for rapid setting polymer patching concrete material. And it's for use on jobs with small amounts of deck patching that are going to receive a thin epoxy overlay. And I say small amounts of deck patching because they are quite expensive. They run about $2,400 a cubic yard just for the material alone. But as you know, time is money. And these small deck patches using the non-cementitious patching materials can be overlaid after 1 day versus 28. Also, at an AASHTO TSB2 Bridge Preservation Partnership meeting, I learned about the research project, KTRAN KSU 13.3, the effects of concrete moisture on polymer overlay bond over new concrete. And that inspired a research submittal that I put in to research Michigan bridge concrete and the epoxy materials that we use to see if we could come up with a similar result with our mix designs to reduce the age of the concrete at the time of the application. So this presentation, I'm going to transition here into kind of presenting on the results of the research project. It's in a state of almost being complete. They're in the final draft of the report. And this is detailing MDOT's research into reducing the concrete age. But before I begin, I want to note that some of the presentation does have specific product names used, and we don't want to say that this is an endorsement of any of those products. We just chose 2 epoxies that we commonly see in Michigan being used by our contractors and our maintenance crews. This is to determine the concrete age of standard MDOT bridge deck concrete mixes and patching mixes can be reduced at time of thin polymer overlay application. In order to measure this, Western Michigan University looked at several different variables. They looked at T1. T1 is the maximum wet curing duration for the concrete to either T1A reach the flexural and compressive strength requirement that we have in our mix design, T1B to develop a discontinuous pore structure within the concrete, or T1C to develop total permeable voids to ensure concrete durability from air entrainment. They looked at time to cracking, which is T2. They looked at time to reach an industry standard for moisture vapor emission rate, which is T3. They looked at T4, which was the time to the concrete to reach 250 psi tensile strength, which is required to pass the overlay pull-off strength test. And they lastly looked at T5, which is the time to reach 250 psi bond strength between the epoxy overlay and the concrete. We also looked at 2 MDOT bridge deck mixes. We looked at our grade DM and we looked at our grade BDJR. The grade DM, you can see, substitutes some of the type 1 cement with ground granulated blast furnace slag. So we have 2 different mixes. There's a lot of information on this sheet right here, but basically it's a summary of all the different tests that are going to be run and how many of them and at what age of concrete and what age of thin overlay application. Basically, we had to fabricate, Western Michigan had to fabricate 48 40-inch by 40-inch by 9-inch concrete slabs and 24 6 by 6 20-inch beams to run all of their tests. If anyone wants more information on this right here, we'll be able to send out the report. Once it's complete, just send me an email and I'll get that to you. So here's just some pictures of some of the process at the Turney Group where all of the concrete slabs were made. It was a collaborative effort. We had several people from MDOT. We had we had TSP2 industry partners there, as well as Western Michigan University and Turney Group staff. So they're starting to get into the results after they poured the concrete and looking at some of the results. They just first looked at wet curing duration for our grade DM concrete. So you'd want to make sure that this would be the minimum which we could apply an overlay. To meet the strength was 7 days. To meet the discontinuous capillary pore structure took 9 days and wet curing, and to meet the porosity, it took 10 days of wet curing. This, as a side note, ended up pointing out to MDOT that we do not wet cure our grade DM concrete long enough to get the durability that we want. Right now, we only have a 7-day wet cure for our grade DM concrete. So that was just an added bonus of this research project. For the grade BDJR, you can see that for all 3 of those variables, the maximum amount of time was 7 days. We also looked at concrete at the time of cracking. Grade DM cracked at 20 days, so we wanted to make sure that the concrete had cracked before we placed the thin epoxy overlay. And for our grade BDJR, it cracked at 18 days. This kind of looks at the moisture vapor emission rate. Industry standard for placing an epoxy overlay on a concrete slab is less than 3 pounds per 1,000 square feet in a 24-hour period. We kind of surveyed a couple other states on what they use for moisture content for applying thin epoxy overlays, and we got roughly 4.5% to 5% is the threshold that you have to be under from Wisconsin and New York DOTs. You can see that our grade DM concrete never actually hits the moisture vapor emission rate industry. But to get underneath the moisture content percents that a few other DOTs use, our grade DM concrete hit that in 14 days, and our grade BDJR concrete hit that in 17. When they did the testing, just to let you know, this is kind of a flow chart of how they looked at it. They tested our slabs that they made at room temperature, 73 degrees Fahrenheit. They tested our slabs at an elevated temperature of 110 degrees Fahrenheit, and they tested our slabs after alternating wet-dry cycles with a 3% salt solution flooded on the top of them. Here's some of the testing equipment in the lab that they used to heat up the slabs to 110 degrees. And another thing that we did was, once they were done in the lab, we were like, hey, why don't you take them outside, ship them over from the Turney group over to Western Michigan University's engineering building parking lot, and let them sit there and percolate for a couple of winters in Michigan weather. Give a little detail on the different failure modes you can have in a tensile pull-off strength test. Thin epoxy overlays. Type A is what you're looking for. It's where the epoxy does not fail, the bond does not fail. What it does is it fails the concrete. Type B failure is a bond failure between the concrete and the overlay interface. A type C failure is a failure in the overlay. You have 2 layers of thin epoxy overlay, and you don't want a failure in the overlay. And then type D is a bond failure between your testing machine and the epoxy. Okay, so for in-lab testing, you can see in the upper left-hand graph that nearly all of the tests came back as passing for greater than 250 PSI pull-off. The upper right, you can see that nearly all of the slabs came back greater than 250 PSI in the pull-off test for when they were tested after wet-dry cycles of a salt solution. But you look at the bottom left, all of the slabs, a lot of the slabs that were tested at 110 degrees Fahrenheit failed. You can look at they all failed. On the bottom, you can see that they all failed while heated at 110, but then they retested them once they had cooled back down to room temperature, and they all passed again. Epoxy overlay performance. Now, this is some of the results that we had from the parking lot and comparing to the lab tests. They performed some outdoor testing in October of 2019. The ambient temperature was 48 to 50 degrees. The slabs were all greater than 200 days old at that point. And then they also tested them in February of 2020 when the ambient temperature outside was about 34 degrees. And all of the slabs, irrespective of how old the concrete was when the overlay was applied, they all passed the pull-off test. However, all of the pull-off tests in July of 2020, when the outside temperature was 90, those failed. Those were less than 250 PSI. You can see here some of what the failed surfaces look like. You can see in the upper left-hand corner, failure at room temperature. You can see that the you can see some aggregate exposed. You can see the failure was in the concrete. You can also see in the upper right the failure was in the concrete after the wet-dry cycle. And then you can see in the elevated temperature the smooth surface left behind, indicating that the failed surface is the bond interface. But in the bottom, in the middle right, you can see that after the heat cycle, that same slab, once it had cooled down, then failed in the concrete. And then outside, the ones tested in the summer, they were kind of a mix. There wasn't necessarily, there was primarily a failure in the interface, but then there was a little bit of failure in the concrete as well. So epoxy overlay performance, based on these results, MDOT. So basically what it's saying is that several manufacturers limit their substrate temperatures to 90 degrees or 100 degrees at time of installation of thin epoxy overlay. And it's indicating that we need to update our specification to put an upper bound on the temperature at time of installation, because right now it only has a lower bound in our specification. So this is the results of all of the tests. You can see that for grade DM, that you shouldn't put the thin polymer overlay on the concrete at less than 20 days old. And for the BDJR, you should not put it on the concrete at less than 18 days old. So the recommendations from the research project that they're going to be giving to MDOT, epoxy overlays can be applied on bridge decks when grade DM concrete is 20 days, like I said, BDJR 18 days. And they are indicating that grade DM is giving us better results overall and over time. So right now they want us to also upgrade our specification to say, do not perform surface preparation or installation of epoxy overlay on patches with grade DM or BDJR concrete less than 21 days of age. Right now it says 28 days. So 1 week may not sound like a lot, but when you're talking about multiple lanes, multiple lane closures, multiple stages of construction, shaving off 1 week will add up quite significantly to your construction jobs. So moving forward beyond this project, let me say during the research project, when we started getting back some of the results, we asked the question, would pre-treating the concrete with a 100% silane before the application of an epoxy overlay reduce the vapor transmission rates of the concrete and improve the bond strength? So we made an amendment to the research contract to add that work for them to investigate. A lot of information here. But basically what you're seeing is at early age, it does improve the bond strength. And the older the concrete gets, the less of an impact it has using a silane pretreatment. But at the same time, it doesn't show any negative impact to applying the thin polymer silane before the thin polymer overlays. It probably needs a little more research to check a couple more silanes and a couple more epoxy materials to check for material compatibility. But our initial results on applying pretreatment of silane is that it will improve the bond strength at early age at room temperature. It shows no adverse impact on thin epoxy overlay performance. And what I forgot to mention on the last slide was it still didn't improve the performance at high temperatures. So our next steps will be field trials that we're going to begin installing by our state maintenance crews this coming summer. And there's my email address if anyone wants to report.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.